Okay, so welcome back once again, guys. Now, in this lecture, I'll be talking about a uniform distribution, which is a part of a continuous distribution, a continuous probability distribution, you can say. So, let's talk about what is that uniform distribution, how it is going to work. Uniform distribution. Yeah. So basically, uniform distribution is a part of a continuous distribution. And when I say a word continuous, it simply means that I'm talking about some area, or maybe I'm talking about some continuity. Yeah. Now, what does that mean, by the way? So basically, continuous uniform distribution, always it will be having a constant probability across a given interval. So whatever interval which I'm going to choose, so let's suppose from A to B, this is the interval I'm going to choose. So occurrence of or probability of anything happens in between or occurring in between this interval will be having a constant probability across this interval A and a B. This is what it means. So every value, so whatever value that we are going to put up or whatever value that we are going to choose, so every value within this interval is equally likely it will be having a probability, or I can say that every value within this interval is equally likely to occur. So whether I'm talking about this red dot or maybe this red dot, this red dot, this red dot, this red dot, and it's called as a continuous distribution. And again, continuous distribution is a broader term. Inside that, there is a uniform distribution, means it will be having a uniformity. So across this particular region, which I'm going to talk about. So now, if I'll talk about a probability density function for this uniform distribution, PDF. So this function is nothing but 1 minus 1 divided by B minus A, right? Where for A in between X in between A to B, X in between A to B. So this is what it says, by the way. Yeah. So X will be in between A to B. So any kind of a given data will be in between A to B. Now let's try to understand it with the help of a problem statement, right? So here my question says that, let's suppose my question says that a student, right? A student scores randomly between 50 to 100. Yeah, 50 to 100 marks in test. Yeah. So basically the range is basically 50 to 100, which is given to me. Fine. Now, what is the probability that student scores between 70 and 80? So what is a probability? What is a probability that student score between 80, right? Or I can say 70 to 80. 70 to 80. So I can say that this 70 to 80 is falling between these ranges. So let's suppose my A is equals to 50 and my B is equals to technically 100, right? So this is something given to me. Yeah, this is something given to me. Now question is that what is the probability that a student scores between 70 to 80? So obviously 70 to 80 will be falling between this particular range itself. And I know that as per the uniform distribution, the chances of happening this particular event is equally likely in this particular region. So I can try to use this f of x or probability density function. And first of all, if I'm going to calculate B minus A. So my B is equals to 100 minus A, which is 50, is equals to 1 by 50. So this is my f of x I will be able to find out. Now, what is a probability? So probability of basically any kind of a score between 70 to 80. This was the question which has been asked, right? Which has been asked. So I can say that f of x, this probability density function which I am able to calculate into, I can try to give a interval. So 80 minus 70 is equals to 1 by 50 into 10. So this is going to give you 0.20. So there is a 20% chance that if there is a random score between 50 to 100, right? So for this score, there is a 20% of the chance, and this 20% is trying to represent an area, right? the area this is going to occupy, by the way. So this is basically called as a uniform distribution, and based on that, we are able to solve this particular problem. So with that, thank you so much everyone. Take care and see you again in my upcoming lecture.